And we're starting podcast.
Welcome to today's webinar, How Pluribus and Exenta Edge Radically Simplify Private Cloud Storage. My name is Matt Bichelle, Senior Director of Product Marketing at Pluribus Networks. I'll serve as today's moderator. Today's presenters are Oscar Wahlberg. Oscar is Director of Product Management at Exenta. He has over 15 years of enterprise storage management experience. Oscar leads product management for Exenta Store and Exenta Edge, Exenta's next-generation scale-out storage solutions. Prior to Exenta, Oscar was at Symantec in numerous product management roles, including as Senior Principal Technical Product Manager for their emerging storage solutions covering software-defined storage, Hadoop, and object storage, as well as for their Veritas Storage Foundation cluster file system. Our other co-presenter today is Robert Drost. Robert is co-founder and Chief Operations Officer at Pluribus Networks. Prior, Robert was the Senior Distinguished Engineer and Director of Advanced Hardware at Sun Microsystems. Robert has extensive hardware experience, including over 90 patents and a 17-year career in high-performance computing systems. Among other recognitions, Robert has been cited by MIT's Technology Review TR35 as most innovative computing technologist under age 35, and by the Wall Street Journal with a gold medal for innovation in computing systems. So with that, we'll start with Oscar. Oscar, take it away.
Thank you very much, Matt. I wanted to start with a quick introduction to Exenta as a company and where we came from and what we're doing, because a lot of you on the line may not be as familiar as general storage population with who Exenta are. We're really one of the absolutely first software-defined storage companies. We were founded in 2008 with the premise that we can leverage software, intelligent software running on commodity hardware to create storage services. We've had a steady growth, both in number of employees and customers and so forth. Today we're about 200 or 200 plus, I should say, employees. We're headquartered in Santa Clara in the heart of Silicon Valley. We have roughly 6,000 customers, continuously growing, of course. And we have 1.5 exabyte under storage management. So we've really had a tremendous growth of our product set over the years. And really what's fueling this growth is a need to change and a couple of major trends in the industry. That's kind of really what I wanted to start talking about, the different trends that we see in the industry. So Matt, if you switch to the next slide, let's kick it away. So a couple of things have emerged over the last couple of years, I would say, and I think these are going to continue to grow, and you're going to continue these are going to continue to evolve over the next couple of years. But if you think about it, what's really changed the storage landscape, and not just the storage landscape, but also the data center landscape and what customers are struggling with today, is things like social media and rich media content. When we think of social media, we think in general of Facebook, Twitter, YouTube, things like that. What they do on the front end when we use their applications is they create a lot of storage in the back end, for example. So that's really fueling a big change in how applications and how servers and storage are everything coupled together inside the data center. Same thing with the whole notion of big data and analytics, the ability to store data, huge capacities and huge amounts of data over time, and then run analytics on that data to extract, that little extra information that you can gain so that you can get ahead of the competition, for example. That notion of, saving data and analyzing also fuels that storage growth. And now, what I would say really characterizes really emerging is the whole Internet of Things, where we're now talking about adding billions and billions, potentially, of devices that are connected to the Internet. They report back as metering or as information. It's really about your light bulb being connected to your home router, allowing you to turn it off and on from your mobile phone. All of these are connected. They report status and statistics, and that information needs to be stored, managed, and you should be able to act on it. All of this kind of really drives a number of different changes in the data center. I've mentioned storage as being one of them. I think another one is really that it changes how networking is being done in data centers or in modern data centers today. And really, I think this is where Pluribus and Nexenta kind of come together in the sense of, we're going after the software-defined market of we can do more with software. We can help these new challenges in the data center and actually solve them. So on the storage side, we do that through what we call software-defined storage. And that, there's a couple of different things we do in that. One of them is obviously trying to address the storage cost, but also the flexibility. But cost is a big portion of it, so let's talk a bit about that for a second and the kind of the cost of storage in real life. Matt? I'm sure you've all seen these type of slides from Gartner's, IDC, and other analyst firms, and kind of, the storage cost is growing. It's growing exponentially over time. Your budgets are not. How you deal with that? Well, one of the challenges I've seen with that over time, and that we see all the time with Nexenta, is really that the legacy storage vendors and the legacy storage market has had a very high built-in margin. Because it's a prepackaged box. You buy your hard drives, you buy your SSDs, you buy your server and your storage control, everything in a single box. It comes with certain capabilities, and you pay a premium for that. Now, what Nexenta can do with software-defined storage is really decouple the hardware from the software components, allowing you to be smarter about how you acquire hardware, and that really allows you to drive down the storage cost. The flexibility built into the software also allows you to grow when you need to and how you need to, further making sure that you kind of keep that cost of hardware as low as possible. So if we look at it from a high level, the traditional appliance-based storage is really a closed model where you buy a package. You can't really change that package very much, but the software-defined segment allows you a lot more flexibility. There's really no traditional kind of lock-in into hardware. You don't need to buy hardware from a specific vendor. You can actually, in a sense, shop around to get the best price. You don't need to buy the full kit at, day one. You can expand and you can upgrade very easily. Now, all of that sounds really interesting, and it's really important, I think, in the sense of cost, but we still need to provide the enterprise services that you expect from a storage array, right? You still need to match or do better than the traditional storage does. So with Nexenta and Nexenta Store and Nexenta Edge, we still provide a wide variety of access protocol from block, file, and object protocols, and we've integrated into all the the common ecosystems, be it VMware virtualization, Microsoft and OpenStack type environments. And that's really important that it integrates well, it functions as well as the traditional arrays, while still providing you with additional flexibility. And that's really our goal. So let's take a second and talk about the Nexenta storage portfolio. We have essentially a couple of different products. Nexenta Store, which was the product that we launched in 2008, is a scale-up block and file storage solution. It's really geared towards enterprise application, cloud backends, unstructured data repositories, very much a common appliance in everyday data centers today. We also last year launched a product that we call Nexenta Edge. And that's a different product. It's a scale-out model that serves block or object storage. This is really geared towards what I would characterize as next-generation clouds, big data applications that benefit from some of the functionality of flexibility that scale-out gives you, but also some of the unique functionality that we bring with Nexenta Edge. For the virtualization infrastructures that are common in every data center, we have a product line that we call Nexenta Connect that integrates into those solution ecosystems. And later this fall, we're also launching Nexenta Fusion, which is our single pane of glass and orchestration solution for managing our own products. Today I wanted to talk about Nexenta Edge in particular. So if you switch to the next slide, I have a high-level overview of Nexenta Edge. And that's really kind of, I mentioned it as a scale-out solution, and it's really based on x86 servers. I think of it as, a 2U server, a 4U server with direct attached storage, so disks and SSDs in the server, with networking attached. So we support 10 gig networking, for example, 10 gig and above. Many of these servers are connected together to form a cluster. That cluster then provides storage out to clients. We've designed the system to be very, very scalable and very flexible. It's designed to hit the workloads that we talked about in the sense of next generation applications. So OpenStack, active archives, big data applications. And we've focused it around providing high performance, both storage and networking. Because one of the things that's very interesting with scale-out solutions is that when you connect many of these disaggregate storage nodes together, we found that data centers, or historic data centers, I should do, and legacy data centers, were really focused around providing fast communication between clients and servers, north and south, so to speak. Whereas scale-out storage also puts a different challenge on these networks in the sense of providing, we need to provide and we want to provide fast storage between different servers within the data centers. So that's something that's changing, and things like open software-defined networking can also help with that. If we look a bit at the actual key use cases here, if we look at the object archive use case all the way out to the right on this slide, we provide a great archival solution that provide Amazon S3 and OpenStack Swift APIs for object storage. That's really a scale up or a scale out model in the sense of huge capacities. We find customers using Nexenta Edge for this particular use case to store data for a very, a large amount of data in the sense of, we're talking petabytes and petabytes of data that they want to do something with. They store it on an active archive basis. These are quite often what has been characterized as Web 2.0 applications. So for them, it's really important to have strong flexibility, the ability to scale the application, either performance or capacity over time, very independently and flexibly. Now, the next generation clouds in the sense of OpenStack or Docker applications, or what's in general being called cloud-native applications now, they had slightly different demands and higher demands on performance, so we tend to move into environments that we add a bit of flash storage to get performance up. The access method also moves from dominantly object-based to also block-based access, where we provide virtual machine storage to these applications. As we move towards the left and kind of into more classic enterprise application territory, we add more and more flash. And that's kind of the power of software-defined storage in the sense that we are capable of changing the hardware underneath and get different benefits. I wanted to drill down into some of these use cases, in particular OpenStack, the cloud-native application segment, and object storage. Kind of talk a bit about how we integrate into those ecosystems, but also how I think networking is important in those. For OpenStack, one of the key things is that Nexenta Edge really provide all the different storage that you need in an OpenStack environment, be it either virtual machine image storage, data storage, or either through block or object. I think it's important to realize that some of the aspects of these storage solutions, Nexenta Edge lends itself really well to it. We take all the data that's stored in an OpenStack, or actually in any environment, we take all the data we store, we compress it, and we deduplicate it on the fly so that you get a very efficient storage backend. But in these cloud applications, one of the things that's really interesting, I think, is that be it either OpenStack or Docker and container environments, some of the challenges is not only that you have storage challenges and the ability to provide flexible storage, but since you have, in a sense, transient virtual machines or short-lived containers, tying those to persistent storage or networking is actually a really hard task. And I think that's what software-defined storage or software-defined networking really shines. The ability to integrate into ecosystems such as OpenStack or Docker container infrastructures. So with the container infrastructures, we've actually taken it a bit further than the integration with OpenStack today. Today, we actually allow an Exenta Edge to run inside of a container itself, taking storage from the host and then presenting that storage out to other containers. So we can run Exenta Edge as a microservice in a container environment, which is a pretty unique and pretty cool technology. The way we do that is by leveraging networking and storage combined. So coming to the active archive use case, I think one of the things that, again, kind of ties well into networking is the fact that when you scale these environments up to large scale, there's a lot of networking involved between the different servers, from the servers to the client, and having the flexibility to do that is great. We also spend a lot of time optimizing our network backend to actually address not only how we do the transmissions in a high performance manner. We actually have a lot of innovations in a network protocol that we call Replicast to do that. But we also spend a lot of time optimizing our solution for failure scenarios, in the sense of, how do you non-disruptively add, remove nodes? What do we do when you lose devices and so forth? A lot of these issues are important to solve in these big environments because you're always going to have an issue. But really what these content repositories are a great way to do rich media, long-term storage. And that kind of really dovetails into some of what our joint customers are doing. And I'm going to hand it over to Rob here to kind of talk about the Pluribus approach and what we're doing together with customers.
Hey, first, I just want to say thanks for that portion. And for folks on the phone, go ahead and enter any questions you may have. Oscar's covered a lot of great content so far, and I know Robert will as well. So just go ahead and enter any questions in the system, and again, we'll cover them at the end. So with that, Robert.
All right, thank you, Matt. This is Robert Draw speaking now. And thank you very much, Oscar, for that introduction to Exenta and Exenta Edge. It's a really exciting storage technology, and when you're a startup company and you're getting a chance to work with people doing really innovative stuff, it's very cool, and it fits very well with the vision of Pluribus Networks, as you'll see in a moment. I'd like to talk a little bit about, and I'm going to go through a couple slides on Pluribus specifically first, so that people get a little bit of the flavor of what sort of motivated us in our networking space, and then what our key technologies are. And then after that, we're going to have a more, Oscar and I will have a more interactive discussion where we talk about a customer win use case and what really drove that customer to the joint solution, so people can kind of get an idea of what really differentiates Exenta, Pluribus, and then what are the differentiators of using the two companies together in their technologies. Okay, going back to this slide here, data center market and its fundamental transitions. This is sort of if you want to think about, why is Pluribus Networks here at all? Why is, in sort of a post, Cisco era, where people are looking at software-defined networking, what was Pluribus thinking about doing? And, one of our thoughts was that everybody had sort of seen that they needed to have more compute, they needed more storage, they needed more networking, but the IT cost center was getting too expensive. And a lot of people responded to that, and we've seen a huge amount of uptake in the public cloud environment, especially Amazon, AWS. And you know, that's fine for small scale implementations, but you give up a lot of control, and it actually becomes very expensive to run all of your infrastructure on AWS. So there's been a lot of desire to have that sort of technology available in the IT hosted on-prem data centers, really converting what used to be you know, non-dynamic, siloed hardware, be it servers or storage, and of course the networking that connects them, and make it basically as flexible as the kind of reuse and swapping around and so forth that you can do in a public cloud environment. And it's been referred to in a couple of different ways. On this slide, we're calling it IT as a service. So you take a lot of infrastructure that's utilized at maybe 5 or 10% levels, and you get it utilized 70, 80% levels, and you realize tremendous improvements in both the efficiency of managing it and the total cost of what you have. In fact, in a lot of cases, you take your existing hardware and you're able to put a software-defined layer on top of it, and you get huge improvements from that. So that's one big transition that's been happening inside of enterprise data centers. Another one has been that whereas in the past, the client-server model really went to a single server, so you had a lot of north-south traffic going into data centers from the gateway and the exterior world, to now there's a lot more of a decomposition of the computation that needs to be done, be it data mining or collaborative applications that are serving use cases, and Docker is a trend of that, going from VMs to kind of micro VMs and application level services. And the result of that, there's been a lot more east-west traffic between servers when they're doing computation, servers going to databases, servers going to block store, servers going to object store, and so forth. The numbers have gone up from, you know, 20, 30, 40% to well over 80 and 90% now of traffic that you see in a data center is east-west. And so if you still want to have security, and if you want to actually see what's going on, you can't do that by just looking at the gateway north-south devices in your enterprise. You need to actually have a lot more visibility of what's happening in the data center. And so just putting dumb networking devices in there that just move packets doesn't do that anymore. So one of the things Pluribus was interested in was using software definition in the network to allow you to actually put programmatic tapping and intelligence into the network as well. Finally, the third thing that's happened is there's been a tremendous amount of movement, and this slide here was, you know, drawn for the networking side, but I would say it's absolutely the same thing in the storage side, and that's where Nexenta is really soared, has been the movement from going from proprietary hardware, proprietary silicon, and then closed software to going to open software, hardware that's much more flexible, much more cost-effective, and everybody, of course, has been standardizing on, you know, x86 platforms, and more recently we're seeing an uptick of ARM as well, of course. So one of the, you know, big ones you'll see on the left, and we put that deliberately there, is you just don't see these anymore in the server space. We used to have, for instance, full rack servers that were, you know, 30, 40 U devices, you know, weighed a couple thousand pounds, and that was computing in the, you know, mini frame and, you know, the large scale server era. And that ended with Linux and with, you know, rackable x86 servers, where you basically took those boxes and refactored your application, your data center, into a bunch of rack mount servers. And networking, if you look at it right now, if you actually look in a lot of networking spaces, you'll see networking devices that look just like those tall vertical devices. That's the classic old style. In the freedom of choice disaggregation world, in storage, just as in networking, you'll see basically everything is refactored into 1U and 2U boxes, and you basically scale out and compose the functionality of those large closed hardware boxes by a bunch of much smaller, much more nimble, much more cost-effective boxes. Now, what does Pluribus have to offer? I'm going to go through a few slides in a moment of actually some of our differentiated kind of features, but just as an overview, the main thing that Pluribus provides is one operating system that provides all of our SDN features. It provides one fabric on top of it, stitching together a whole bunch of hardware boxes into effectively one CLI, one API, whether it's being run by a DevOps person through Puppet or Ansible or C or Java, or through a NetOps person who's running CLI in the classic mode. And that OS is called NetVisor. NetVisor is a smash together of the words network hypervisor. And it's really unique for us, out of all of the new networking technologies that have come out in the last 6 or 7 years, we really as a company are the only person who looked at it and said, it's not just good enough to move to Linux. You actually need to create at the fundamental level a distributed Linux operating system that runs across a collection of networking hardware, and it provides for you all of the SDN features as a distributed, unified service, single management, single analytics, and it also allows you to do hardware virtualization in the network. I'm not saying you wouldn't necessarily have overlays and VXLAN tunnels and virtualization in the server. You can always do that. But the network itself should not just be a dumb network. It should have the ability to actually put virtualization features in there as well. So, the four sort of, pillars of Pluribus, one of them is a virtualized fabric, which is, of course, very important for infrastructure as a service and private cloud. It basically removes any kind of layer 3 boundaries in the physical network and allows at the network level for you to unite data centers or do micro-segmentation of single racks or multi-racks among multi-tenant use cases and provide QoS. We have analytics that are built into the network, so gone is the day of actually having to tap individual wires. Every single Ethernet port in your network now has the ability to filter, trap packets, capture TCP metadata. It's really an unprecedented power that's been put into the network. We have a whole bunch of automation, which allows you to basically reconfigure your network with a few software commands, and we do have role-based access as well. So it's possible for people who are using the data center to basically be given portions of the network and the network administrators to still have control of the physical underlay of the network. So we actually have sort of a dual layer, network admin / DevOps or security ops or cloud ops admin, where they can work together rather than having to effectively give root control over the network to anybody who wants to reconfigure it. Very much like Linux world, root space and then user space, super user space and user space. And finally, we call it lab automation or L1 switch. In a lot of environments, it's really important to be able to fundamentally make the network look like it's been rewired by a person. You've actually pulled out wires and moved them somewhere else. We actually allow you to do that in the network without moving the wires around. So we're able to actually provide virtual wires that make it seem as if you're fundamentally changing the connectivity, and that will be seen beneath anything else that's happening in your network. So it truly will allow you to, take devices under test, attach them to different loads, reconfigure them, put Ixia devices, whatever kind of test environment you have can be shared among a whole bunch of users. Okay, next slide. So let me dive in a little bit more. I'm going to run through these next 5 slides a little bit more quickly, but everybody who's on the webinar is going to get this slide deck as well as a link to point back to here. And so while there's a lot more content on the slides, I'm just going to touch on the high-level things. And then we want to get into the meat of the webinar, which is going to be the joint solution of Pluribus and Nexenta. So on agility, the main takeaway on this one, that I want to point out here is that the Pluribus networking is very key to the idea that everyone is not going to adopt a new technology like software-defined networking and create a new data center. There's a lot of existing infrastructure out there. There's a lot of, Cisco and other networking vendors, Juniper and so forth, routers and switches in the world. So we designed our technology that you get all of the benefits. There's nothing that is held back in an environment where you basically take some portion of your data center that you want to actually upgrade to Pluribus, and it's just very appropriate in an Nexenta environment because in many cases, especially for Nexenta Edge, you'll have some number of racks that may be storage focused. And this allows you to effectively put together a fabric, which would have been, prior your SAN network, converge it onto your existing Ethernet network. So you're actually getting all the benefits of QoS in a converged space, and you haven't had to give up any of your old networking. we've actually had a number of customers who have pointed out to us that in a real sense, our network is more compatible with Cisco than Cisco. So with Cisco, if you move to a new platform, it's a rip and replace usually. You can't use, for instance, their new ACI SDN platform with mixing together with their old switches. And it makes sense. Cisco actually needs to sell new hardware. That's how they make their revenue. We actually allow you to use all of your existing Cisco at the spine layer, at the aggregation layer, even mixing together with top of racks and so forth. And you just put in the parts of the network that you want on SDN, and you see the benefits of all our technologies. Now, the other big advantage that I touched upon before is that we integrate application analytics. That means that we allow you, whether you're a network admin or a user who's been given the ability to put some software probes into a network, to go ahead and filter, basically packet streams based on any stateless 5-tuple, and you can store them in the network. You can then access them through NFS or redirect them to another location and put them into a file store for later use. So this is basically software-defined tapless tapping, and it's a default thing that comes inside of the network. In third-party networks, we also allow you to go ahead and take span ports where you pull packets into some portion of the NetVisor network, and so you can actually do analysis of your third-party network as well as the inline tapping of your network. And we have another application that I'm just going to verbally describe, but please do feel free to go to Pluribus's website and take a look into it. We have a feature called Time Machine, which is that we actually monitor every TCP flow from a state machine perspective. So everyone's familiar, TCP flows start with, they start with a SYN ACK, and they have a whole bunch of packets, and they end either with reset or a FIN. So we timestamp, measure the metadata, what ports, you actually get physical tracing in L2 networks in order to correlate against congestion. We actually trace and track and give you a metadata database of every single TCP flow that happens inside of the network. So for the portions of the network where the flows are going through Pluribus devices, portions where you've basically moved up to SDN, and this is of course relevant to the Pluribus Nexenta collaboration where you put Pluribus on the top of rack in an Nexenta deployment, you actually get to see all of your TCP flows. It's a tremendous feature that allows you, in a lot of cases, the network engineers really love the ability to be able to sort of prove the network is working well, or to be able to find where there's a problem, and even to do auditing of who's doing what and when. It allows you to actually go back to when a user says 2 a.m. 2 days ago, I saw this problem. Network engineer types a few commands in, they see every flow that happened from 2 a.m. to 2:05 2 days ago or 2 months ago. Of course, with longer going back, you put more storage behind this stuff. And another one is, I'll just touch on this here, for OpenStack and other environments, we allow you to basically do VNets or VPODs, which allows in multi-tenant environments that you can go ahead and segment your physical network to put it among multiple users. In fact, we don't show it on this slide explicitly, but when I show OpenStack and VMware NSX, we actually allow you to host multiple virtualization stacks in the same physical network while putting QoS SLAs around them, something of course you couldn't do in a public cloud environment, and keeping them separated. So it helps very much with converged data centers and consolidation stories for companies that are looking to merge data centers together in different groups. Number 4 is integrated services, and again, I'll just briefly say this, that we have network function virtualization ready. We have a number of virtual functions that are ready inside of the network. So every virtual network gets its own virtual routers, virtual DNS, virtual DHCP, virtual load balancers, virtual firewalls. And then we have some partners who have been putting other things into the network, because our mantra is to actually make the network much more programmable and flexible. And we have even had some customers where they move some portion of their infrastructure to run in the network to get the benefit of the control and visibility that you get from sitting inside rather than peering from the outside of the network. And finally, freedom of choice. And this is a really important point here, which is if you want to have the sort of thing that you're used to, which is, you can have a mix of different server vendors, You can have a mix of different server OSs. You can have a mix of different storage OSs and so forth, storage software, storage hardware. We give that same freedom of choice in the network. You have our software able to run on different hardware. You can run, if you want conventional style, you can buy hardware that's fully branded from Pluribus. It's like you're buying a Cisco box. You can buy Brightbox from companies like Acton, where our software is preloaded and you're getting it direct from China or Taiwan. And then Whitebox is a model we have with companies like Dell, where you're basically buying a piece of hardware, and that's even the most extreme version of this. This is exactly like Linux versus Windows running on Dell. You buy a Dell piece of hardware and you have, I think at this point, 4 or 5 different networking OSs that can run on the same piece of hardware. So you get hardware safety in your investment, as well as the software can run, as you can see, across quite a few different stacks. And finally, one last slide I'm going to show before we start talking about the merged value proposition of our two companies. And this is just, I'm not going to walk through this slide much at all, but this is a kind of overview slide of all of the places where the Pluribus technology is quite valuable. One of the reasons I did put it in the stack is that, and I started putting down the Nexenta logo on these quadrants or on these sextants, and then I realized I'm going to end up putting the Nexenta logo on all 6 of them. So let me not even bother to put it there. Just understand that you can actually utilize our networking technology as well as Nexenta in every single one of these environments. And you see some of the other logos that we have of some of our other major partners. Okay, so let's move on now. So I think it's useful to actually say, things pretty directly. And so, the first slide I'd like before we talk about the use cases, just to explicitly say, why are Pluribus and Nexenta, in our views, a very, very good fit? And I think it comes down to matching architectural visions. Both companies were founded with the idea that you should be able to software define everything in your data center. Nexenta has basically taken what used to be, very kind of physical networking devices, and they've put a software definition layer on top of them that makes all 3 of these types of ways of accessing your storage data extremely dynamic, extremely flexible, growable, and putting all of the sort of features you would have expected on your highest end storage, proprietary hardware into a software-defined world. And similarly, Pluribus went ahead and took everything that you would find inside of a physical network, your ports, your network function, your pods, your L2, L3 networks, and so forth. And we put a little V in front of all of them, or in some cases a capital V. So everything is virtualized. One physical network, you can still run it as a physical network and get, some of the benefits, or you can even virtualize it, and then you end up having multiple layers in layer 2 and layer 3 networks that are sharing the same physical hardware. And when I say that, I really mean that. We have deployments where in a single rack, through a single piece of networking hardware, you have the same MAC address and the same IP address for 2 different users in a multi-tenant environment going through the network and not even noticing that they're overlapping and normally would smash into each other. We're both built for virtual infrastructure. It's exactly the same. We run on the conventional VMware, of course, because there's so much of that deployed. Everybody's looking at doing more and more OpenStack, especially as it's maturing. And we're both basically helping with the emerging container market to basically make that much more flexible and much more powerful. And a third one, and this is a really important portion of the value, I think, for both Nexenta and Pluribus, is that we didn't just want to make things software defined and give users power from the software definition. We also wanted, hidden to the user, to put in hardware acceleration and performance underneath. So you not only get the flexibility and all of the features of software definition, but you actually get very high performance that you would have previously had to have gone to a dedicated hardware purpose-built device for. And so Nexenta has a slew of these technologies. Please don't take it that just because I put this one, this is the only one. If you look through their slides, I think when I was looking through, I saw 5 or 6 things that they did to really make the technology scream in performance. But one of them that's very relevant to the network is Replicast feature, where they literally are using these switch chips in the network in order to accelerate storage data replication. So they offload storage data replication into the network and get a tremendous performance advantage. And this is all using chips that existed already. They're not putting an accelerator in, they're just using the top of rack switch to get a storage performance enhancement. We similarly are using the switching hardware that's inside of the network, and we're exposing VXLAN tunnel acceleration, so we're offloading the tunnels from servers. Becomes very important when you have virtual machine environments, or even now as we're moving to Docker environments, switching your applications to not use a software, or you think you're using a software switch that's inside of the server, but we actually pull those tunnels out of the server and we terminate them inside of the nearest networking device, and we offload the x86 CPU to do useful work rather than doing packet processing. And likewise, we do analytics inline in the network. So all of the analytics classification is done in hardware so that it doesn't affect the latency, it doesn't affect the bandwidth. In a sense, we're going against Heisenberg's principle of uncertainty here. We're allowing you to actually look at something without disturbing it. But we're not at the quantum level, so we don't actually break physics. But we are breaking the normal data center rules here. We are allowing you to look at analytics inline. This is like GDB without slowing down your code. You're seeing the real traffic without affecting it when you're debugging problems. Okay, next slide. And one point I just wanted to say here is, Nexenta has this beautiful stack here with store and edge on the bottom, two very different complementary storage technologies, and then connect and fusion on the top. The way you should think of the relationship, and I'm going to in the next slide talk about the technologies, we have technologies that allow you to basically improve things or improve the network's use for both Nexenta Store and Nexenta Edge. So let's jump to the next slide where I talk about that a little bit more. So we have, for instance, two analytics technologies, one packet analytics and the other insight. In Nexenta Store and Nexenta Edge, there's a mix of TCP and UDP traffic flows. We allow you to basically capture UDP traffic flows for debugging or for application optimization, storage optimization. And like I mentioned, we have the TCP timestamping and metadata full packet capture. And so as a result of that, for Nexenta Store, you see, which is more heavily TCP based, you get the ability to see virtually everything that's moving between your storage cluster as well as from your storage servers to your storage clients. In Nexenta Edge, on the packet analytics side, everything is relevant. On the insight analytics side, because of the performance optimizations on the right side, the metadata TCP flow capture is relevant mostly to the read traffic, which in a lot of storage systems is the majority anyway. So the read traffic is captured at 100%. And if you look at the quote on the side, this is a recent report from Gartner. They're basically advising heavily for people who are looking to hyper-converge their data centers, meaning they're looking to basically use, for cost and management reasons, one data center with common usage for storage, for conventional traffic, and for VDI. You don't want to treat your network as fat dumb pipes anymore. You have problems troubleshooting, and you can't see things from an end-to-end perspective. And if anybody wants to talk or read more about that, I can also, I didn't include it here, but there's a link to at least the sort of two-page summary of that document that Gartner put out, and I'd be happy to share it with you. We have our email info at the end. So let's get now to the meat of this. We meaning Nexenta and Pluribus, essentially won a deployment in a leading U.S. university. The university has a policy of not having its name attached to case studies. That's the reason why it's not shown here. But trust me, if you're putting your child into college next year and they're going to this university, you'd be very happy, except you might be pretty poor. So this joint case study, basically the motivation for us talking with this university was that this university, like many others, had a big push to move items into the cloud. The reason why was not that they loved the cloud per se, but that they had so many problems with the way private infrastructure was managed. All the different groups in the university would get their grants, set up data centers, then they would abandon them or move them around, and you just ended up with a lot of disjoint hardware that was very difficult to run, very difficult to manage, and very underutilized. And so the cloud offered the ability that you could basically reuse things and spin up and so forth. The problem, of course, is that clouds work well at a small scale, but you don't have SLAs. So if you have anything that's performance related, that's sort of out the window. And it actually gets very expensive. If you have a constant compute load, you can end up spending 4 or 5 times as much money on cloud services rather than using it in a private infrastructure if you can manage it well compared to public cloud. And so they basically were looking to make a private cloud that had a lot of the features of what they would have gotten in an AWS. And of course, storage matters a lot in that environment. They had, gigabyte size objects that they wanted to be able to move, around, as well as megabyte and kilobyte objects. And, they wanted to be able to have very high resiliency, meaning lots of copies across racks, across redundant data centers, triple redundancy in this case. And flexibility was key. I mean, the projects and students and professors come and go. People need to be able to take existing storage, existing servers, and existing network capacity and reallocate it without losing it. Okay, next slide. So, so what they decided was the goal was no more data centers, avoid the high cost of a public cloud, and basically have the ability to match the ephemeral needs, meaning people ask for something, it might be a 3-month project, it's here, it's gone, you give it, you take it back, sort of returning that power and that flexibility. There's some technical specific needs and reasons. One, I'm not going to run through those, but if you're interested in those, there were really significant hardware and software differences that the two companies offered. And so it's not just that they saw higher performance, higher utilization, it worked better on many, many fronts. And you can see the quote there, at the bottom of, basically talking about the sub-microsecond latency and so forth. So they really showed to their users and everybody who's using that environment now at this university that they could have the software flexibility out of an AWS while also being able to run it on-site with much better performance and, with that cost advantage, actually cost advantage over a public cloud environment. And again, I'm not going to walk through this diagram as well. If people want to on the questions, then we can, but I don't want to sort of, talk about it more than necessary. But I do like when it's a use case, one of the sort of things I don't like in a webinar is you show a use case, show the topology, show what was actually done here. What we're showing here is the initial architecture, and this is for a storage use case that actually grows with capacity because the users of this are not, in many cases, putting something in and then taking it out of the storage. So the storage footprint started off with this initial deployment, and it is growing over time. All right, and so the summary and sort of the takeaway points that we're going to leave this slide up while we're doing questions. Just, if you had 3 things that you took away from this webinar that you just sort of remembered, and feel free, by the way, both Oscar and I have put our, our business emails on there. You don't have to, if you're interested in the stuff, you don't have to go in directly through the website. Feel free to just reach out to us directly. We're more than happy to kind of talk with you, follow up the discussion, keep it going, and then if it's appropriate, only of course, to have a follow-up with somebody else in our organization. But if the 3 things you take away from here is that this is really a webinar about software-defined, what you can get with really embracing software definition in storage as well as in networking, just like you have already with virtualization and so forth on your server side. Nexenta and Pluribus are both leaders in their respective markets, thought leaders as well as market leaders. We're both very, safe companies and safe bets to play with. At this point, you saw some of the names. We have, OEMs and, Pluribus, Nexenta, I mean, no question from just the stats of what they showed there. Pluribus, I didn't actually show you kind of our blurb slide about customers and so forth, but we have our stuff deployed in 20+ different countries around the world, 24/7 support. Mission critical stuff is running on it. In fact, one of the hardest environments for networking is probably the telco mobile backend environment. And if you notice on one of the slides, we put there that the company Ericsson is actually OEMing and putting our networking software as the networking data center software for 5G rollout. So, whether you go with Pluribus now as a customer or not, within 2-year time frame, your cell phone is going to be running on a Pluribus network anyway.
Okay, well, that's a great segue. We've got time for just a couple of questions because that was super thorough from both Robert and Oscar. So, from whether it's from Ericsson or a top university, could both Robert and Oscar kind of comment on why you might think that university joint use case is such a good one? I mean, I can kind of think about the fact that they were looking for SLAs, that cost was an issue, that they didn't want to go into the cloud. It seemed to touch a lot of kind of touch points that can apply to a lot of other use cases together. What's your take on why that was such a good use case?
Let me make one comment and then I'll let Oscar follow it on. I mean, I think in that case, as well as in a lot of ones for people who are in on this call, I think the first thing is that Nexenta just had so many advantages over any other storage solution, and so I think the primary portion of that whole thing really is the backbreaking work on winning that deal was on Nexenta, and then in a sense the cherry on the top was the choice of network with Pluribus made it even a little bit better. Oscar, what would you say?
Yeah, I mean, I think that's it's been a university that we worked with a long time. We've got a great relationship with them. Obviously, for me, one of the things that I think really kind of won the deal in that sense is the flexibility, right? They were looking for something that was as flexible as a cloud or an external cloud in that sense, with it flexibility of how do I grow this, how do I work with this over time, right? I don't necessarily need to start with a huge infrastructure. I can start with something smaller and grow. And then, Nexenta Edge is a great fit for that. But also, as you mentioned with Pluribus, we have some integration with the Pluribus NetVisor OS that we don't have with other switches in the sense of MLD, snooping support, and so forth. So really a very highly effective and optimized overall solution.
Okay, excellent. Yeah, I mean, that's I think that's kind of why we kind of we work so well together. Now, one of the other popular things that tends to come up, and you mentioned it, Oscar and Space, is about AWS and Amazon, and for this use case as well, that they didn't want the researchers going up to the cloud. It tends to be A, very costly, and B, it leads to shadow IT. And yet, in one of your kind of almost like a growth spectrum of use cases, you had AWS and S3, but you kind of viewed it as almost like an API, like you work with them. Could you elaborate just a little bit more on AWS and how Nexenta either works with it or people have almost avoided AWS?
Absolutely. Yeah, no, I think it's funny because you hit all of my key points there. A lot of customers that we see that at some point in the past they've started using AWS for a minor task. They realize, hey, this is easy. I can get my compute VM up here. I can do something, and they kind of deploy that way. And they use Amazon S3 storage, object-based storage in the cloud for the time being. But then, after a while, when they start putting more and more applications, or even not just applications, but even just more users, they realize that the compute cost and the storage cost isn't, just a one-time fee, right? It adds up pretty quickly in AWS solutions, especially if you read back a lot of data. So what we've seen a trend of happening now is really, customers that early on was early adopters of AWS are now starting to pull back as they realize that, hey, I'm spending a lot of money up here, and I don't own anything. It's really hard for me to actually pull back that data. What Nexenta Edge actually allows you to do is pull back that data, store it in an S3 API, or an object storage on your premise that provides the same S3 API capabilities so that you can, basically pull back your application and run it in-house again.
Yeah, excellent, excellent. So I wanted to just ask a real obvious question: is what would the university have done if not for the Nexenta Pluribus solution? Was it just status quo as is, or was there really a competing technology out there? And conversely, what was it, again, that was so unique about the joint solution for them? Either Robert or Oscar.
I think it would be good for Oscar to take this one, yeah.
I was going to have you start there, Robert. No, no. I think there's, for me, it's a synergy between the two different companies that are really, a really strong proponent of, going with a joint solution. I think we both, have realized that the software-defined space really changes the game. And that means that we're well suited to work together, not just now, but over time, right? It gives you a lot of flexibility, not just in the choice of your hardware in the sense of, the server architecture and so forth for the actual product, but also in your switching infrastructure as well.
Mm-hmm. Very good. And I'll just say, because, Oscar, I think, is being a little bit more demure, but really, the Nexenta storage technologies are really quite unique when you put together the total feature set and the flexibility with which they can smoothly scale from, hundreds of terabytes to, petabytes, and then, eventually, I'm sure they'll see deployments that are in the exabyte range for some of their massive cases. And that scalability is, a key feature. And they've made sure that they don't have, from a kind of architect's or computer science perspective, some portion of their algorithm that has an order of operation that would blow up at a large scale. Everything is kept to, kind of linear scaling or even better logarithmic scaling or so forth, so that they're able to manage the largest environments.
Okay, well, I think that's a great way to kind of close the webinar. Again, we covered a ton of material. Just for everyone on, for any questions you didn't get to, we'll have Robert and or Oscar get to you directly and or feel free to rewrite to them, but we've got the questions here that we did not get to. Again, this recording will be available, the slides will be available. A big thank you to Robert and to Oscar, and to everyone on the call. Thank you for joining us today. We really appreciate it. Thanks, everyone.
Thanks. Yeah, thank you.